Hey everybody, Mr. Mal here going over day 8 notes for Unit 7, factoring polynomials by grouping. Today we're going to factor by grouping. That's going to be our learning target. We'll be able to do that by the end of this notes. And you guys actually have a little bit experience doing this, and I'll show you how in a minute, but you have seen something like this before. So let's jump right into it. Let's get into example 1. A rectangular shoebox is represented by the given side lengths. Write a polynomial expression that represents the volume of the shoebox. Okay, so what I've got here are 3 dimensions given to me of this shoebox, and if you remember, when we're trying to find volume, that's going to be length times width times height. Okay? They give us all 3 of those with these 3 polynomials or binomials. So what I'm going to do is just multiply all those 3 together. I'll rewrite those up at the top. I'm going to have x plus 5, x minus 5, and the other one is 4x plus 3. If you notice right away, these first 2 terms here, if you picked up on the difference of squares pattern, we know that these middle terms of the first 2 are going to cancel out. Now, if I wanted to just FOIL out each one, and then just cancel out those middle terms once we see it, you can do that, and that's fine too. But some of you may be able to pick up that that's going to be a difference of squares right off the bat. And in doing so, you know we're just going to rewrite it as x squared minus 25. Okay? So that's going to be the product of our first 2 binomials that we've multiplied out. So we're just going to take that product, multiply it by our remaining binomial of 4x plus 3. Let's go ahead and distribute that x squared to the 4x and the 3. First, x squared times 4x is going to be 4x to the third. That second term is going to be x squared times 3. That's a positive 3x squared. Over to the inside terms, negative 25 times 4x is going to be negative 100x. And then finally, a negative 25 times a positive 3 for negative 75. So there is our expression that represents the volume of that shoebox. Okay, let's move on. The volume of a rectangular aquarium is represented by the expression x to the third minus 4x plus 5x squared minus 20. Factor the polynomial completely to identify an expression for each side length of the aquarium. Okay, so let's do it. We're actually going to go down to this box right here. That's where we're going to do all the work for this, because this is the key aspect of what we're going to be going through today. All right. So step 1, rewrite the polynomial in standard form. If you notice right away, the first term, this is in the correct spot because this term has the highest exponent degree of any of the terms in the expression. Okay, so that's good. But the next highest is going to be this 5x squared. That's not the next term, though, so we need to reorder that in descending order, right? That's our standard form. Okay, so let's rewrite it as x to the third plus 5x squared minus 4x minus 20. All right, so now that we've rewritten in standard form, what's our step 2? Okay, so now step 2. Group the first 2 and the last 2 terms, okay? So my first 2 terms going to be x to the third and 5x squared, and the last 2 is going to be negative 4x and negative 20. Step 3, factor out the GCF of the first 2 terms and the last 2 terms. Okay, so you guys now have experience factoring out the GCFs, and this is what I was talking about where you guys have a little bit of experience doing this. You did this when you had to split the middle term of a trinomial when you multiplied a and c, figure out what multiplies to c but adds to b, and so on. Okay, this is very similar to that. It's really the same thing. However, they just given you 4 terms to start as opposed to you creating 4 terms. Okay, so let's find the GCF of our first binomial, x to the third plus 5x squared. If you notice, our coefficients are 1 and 5. Difficult to get a GCF out of that, considering one of them is the number 1. So there's really no numerical value coming out. But what is coming out is some number, some degree of the variables. x to the third here, and this second term goes x to the second, because both of them at least go squared, go x to the second. I can take out that value out of that binomial. So I'm going to take out x squared. And when I factor out an x squared, I'm left with inside x plus 5. So if I were to distribute that x squared, I would get this top expression right here. Okay, let's do the same thing we just did, but now with our second binomial. I've got negative 4x minus 20. Well, now I notice that not each term has variables, so I'm not going to be taking out a variable. But they are nice even coefficients that I can take a GCF from, okay? So the first one is negative 4. The second one is negative 20. Because both of these terms are negative, I'm going to make whatever I take out negative as well. So I'm going to have negative 4x minus 20. I can take out a negative 4 out of each, right? Because negative 4 obviously goes evenly into negative 4. And it's going to go evenly into negative 20. It's going to go into negative 4 one time and negative 25 times. So if I take out that negative 4, inside the parentheses is going to be x plus 5, because remember when we distribute it, we want that final term to be negative. So it's going to be x plus 5. All right? And you'll know when you're doing this if you've rewritten inside the parentheses correct, because if typically when we're factoring out this step 4, it says factor out a common binomial. If both of your terms in the parentheses, both your binomials in the parentheses are the same, we know we can factor out a common binomial. All right? So what we're going to do is we're going to rewrite our factored out expression down here, because I have x plus 5 multiplying both of these GCFs. I know that's going to be the binomial we are factoring out. So that's going to be one of them. And the other one is actually going to be a combination of the terms we factored out, this x squared and this minus 4. The way we're going to write it is just simply how it is there, a positive x squared and a negative 4. And you might notice right away that that second binomial is actually another difference of squares. So I'm going to zoom in. We got to rewrite that because it does say factor out completely. So we're going to have x plus 5. Remember our difference of squares. This is going to be a squaring of negative 2. Sorry, of just 2. So this will be x plus 2, x minus 2. There is our factored out completely expression. So now let's go ahead and look at some of the other examples. Here I've got factor out a common binomial. So this is going to be one that's actually kind of already broken down for us. The common binomial, you may have noticed, is going to be x plus 4. So if we factor out an x plus 4, we are going to be left with these two terms that we just need to rewrite as a binomial, and that's going to be 2x minus 3. Okay, moving on to the next one. We've got 3x squared plus 5. 3x squared times the binomial x minus 2, and then a positive 5 times the binomial x minus 2. We're going to do the same thing. We notice that this binomial is the same as that binomial. That is our common one we're factoring out. X minus 2 times 3x squared. Got that from right here. Plus 5. That's coming from right here. Now, example 2 is going to be a little different for us because they didn't already group it and take those binomials together. Okay, so let's go ahead and do it ourselves. If you remember, step 1 is to rewrite the polynomial in standard form. Well, this one is already with our leading coefficient, our first term with the largest exponent. Second one is the next one down, third, and so on. So we're good there. The next step is going to be to factor our first two terms, to group our first two terms, and then group our second two terms. After we've done that, remember the next step is to factor a GCF out of each of those groupings. So our first group, x to the third plus 2x squared. What can I take out of both of those terms? What's the greatest common factor? Well, again, one of them, the coefficient is 1, so taking a number factor out of there is going to be difficult. But we do have variables being raised to different degrees, so we can take out to some degree a variable. The first one is x to the third, the second one is x squared, so I can take out at least an x squared. Take out an x squared, what's left in the parentheses, our new binomial is going to be x plus 2. Let's take a look at our second binomial now. 8x plus 16. Again, these two terms, not each of them has a variable, so we're going to be factoring out only a numerical value. In this case, I'm going to make it 8 because 8 goes nicely into 8 itself, and 16 goes into 16 two times. So if I take out a positive 8, I would be distributing it then to a new expression in the parentheses of x plus 2. This binomial matches this one, so we know that's our common binomial. We are factoring out x plus 2. And then we've got a new expression, new binomial of x squared, coming from right here, plus 8, that term coming from right there. And we're left with the final expression of x plus 2 as the first binomial, and our second binomial is x squared plus 8. So let's go with example B. We've got 5x squared plus x to the third minus 9x minus 45. Again, we're going to notice right away we need to rewrite this one because this exponent degree is higher than the first term they had there. So let's rewrite it in standard form as x to the third plus 5x squared minus 9x minus 45. All right, the next step is to group our first two terms. Sorry, remember we're just working with these ones right now, not necessarily that first expression. So let me just go ahead and actually put the parentheses down here, so better visual for you guys. And then our second two terms being grouped are negative 9x and negative 45. Let's factor out GCF of the first binomial, x to the third plus 5x squared. I'm going to take out an x squared. Can't take out a numerical value, but I can take out an x squared out of each of those, leaving me with x plus 5 in the parentheses. Negative 9x minus 45, what can I take out of there? Well, I can take out a negative 9. That's as high as I can go since the first term only goes that high. If I take out a negative 9, I'm left with an x plus 5. Which is what I'm looking for, okay? So, what do we notice here? Well, again, we've got our common binomial, so we know we're going to be able to factor out this binomial of x plus 5. What we'd be left with is x squared minus 9. However, hopefully some of you noticed that we're not done immediately after that because this second binomial is a difference of squares. So, what's being squared? X. And then the other term being squared would be 3. So we know we can just rewrite this as nothing changes with the first binomial, but we split the second one into x plus 3 and x minus 3. And now we've completely factored out the expression. All right, so let's go over a few more difficult examples of completely factoring out polynomials. Let's look at the first one. 3x to the third plus 6x squared minus 9x minus 18. All right, let's see if I can factor out a GCF. Well, one of the first things I notice is that I can take a 3 out of all of these terms. So I'm going to do that. Take out a 3. Remember, when we have division of a polynomial by just a monomial, we're just dividing the coefficients, subtracting the exponents. In this case, we're not dividing by an exponent, so we don't need to worry about the degrees for that. So let's just divide out the coefficients. I've got 3x to the third divided by 3. That's going to simplify down to x to the third. And then I'm going to do 6x squared divided by 3. That's just going to be a positive 2x squared. And then I'm going to get a negative 3x and a negative 6. Let's carry out those steps we're used to now. I'm going to group together these two and group together these two. What can I take out of this first binomial? I notice that both of them have at least an x squared. Let's take out an x squared from that. If I take out an x squared, I'm going to be left with x plus 2. And if I take out a negative 3 from this second binomial, take out that negative 3, if I were to factor it out, it would be an x. This would be a positive 2, because remember, we have a negative 3 that we took out. Positive and a negative multiplied together is a negative. So now we've got x squared minus 3 as one of our binomials, and our common binomial factored out is x plus 2. Now some of you guys might think we're done right there, but remember, we took out this 3 at the beginning, so what we need to do is still completely factor it out. We need to write that right there. So there is our final answer. Okay, because that circle went through that answer, or our next problem, I'm going to get rid of it there. So our final factored out answer is going to be 3 times the binomial x squared minus 3 and the binomial x plus 2. Let's go on to B. This one is going to be a little tricky, so follow closely, okay? We've got negative 16x squared plus 42x plus 18. Well, I want to try and factor out something that all these have in common. Immediately I notice they're all even. And I don't really think it's going to be that easy for me to factor out a bigger number than 2, because I have 16 and 18. Those numbers are close together, so a lot of the factors aren't going to necessarily be the same. But I do know 2 goes into all these, so let's factor out a 2. I'm actually going to factor out a negative 2. You wouldn't be wrong if you didn't make that 2 negative. But because I have a leading coefficient that's negative, I always like when that leading coefficient becomes positive. So I'm going to factor out a negative to make that so. So I'm going to factor out a negative 2, and divide by a negative 2. Let's go through it. Negative 16 divided by negative 2 is going to leave me with a positive 8x squared. 42x divided by negative 2. So now this is going to turn negative, and it's going to become minus 21x minus 9. So now I've got a trinomial that is not a perfect square trinomial. And I'm going to probably have to do a little diamond math here. And I'm going to do my steps that we went through in a previous lesson, where we multiply the a term and the c term to see what multiplies to get that and combines to become my middle term in the middle, which is still negative 21. So if I were to multiply my a and c term, I'm going to get 72, or a negative 72. That's going to have to, a combination of numbers that multiply to that are also going to have to add to a negative 21. So what I was doing was I decided I'm going to go through the factors of 72, because it's not exactly an easy number to think about the multiplications for and whatnot. So I just started from the top and bottom. So I know automatically 72 times 1 would give me, or negative I should say, would give me a negative 72, but that's not going to add to a negative 21. So I cut it in half. What's 72 divided by 2? So then I would have had a negative 36. And 2, closer, but still not it. All right, well, let's divide it by 3. What is 72 cut in thirds? So that's going to be negative 24 and a positive 3. That, combined together, would get me a negative 21. So those are going to be the numbers I'm going to do. So what I'm going to do is replace my b term with new b terms of these coefficients. So I'll have 8x squared minus 24x. Remember, it is important which order you go in and where you place the negative, because if I made the 3 negative, I wouldn't have the answer I need, right? I wouldn't get a combination to negative 21x. 8x squared minus 24x plus 3x. I'm going to go ahead and erase this for now, just to give me a little more room. Plus 3x, and then minus 9 is still going to tag along with me. That's going to stay there. Okay? I already kind of put the parentheses around the first grouping. I'll put it around the second grouping. Now we just carry on like we already know how to do. What can I take out of this first binomial? I know I can take out an 8, so I'm going to take out that 8. Then I'll have multiplying into an x squared minus 3. Or sorry, I can take out, actually going to go back for a second. I can take out an 8x, excuse me, and now it's going to be x minus 3. And then for the second binomial, I can take out a positive 3. Take out that positive 3, I'm left with x minus 3. Now I've got two binomials that add up. That's what we're looking for. Okay, so what's our final factored out expression going to be? Well, we started out factoring with a negative 2. So we got to start with that. So it's going to be negative 2 times 8x plus 3 times x minus 3. Where did I get all these? We started with that. Then we combine this term and this term. And then we take out our common binomial, which is x minus 3, put it all together to get a final expression of negative 2 times the binomial 8x plus 3 times the binomial x minus 3. All right, let's go to C. Oh, it looks like there's two C's on there. That's all right. I've got x to the third minus 25x. Okay, well, immediately I can take away one of those x's, right? So let's do that. Let's take away an x. I'm going to have x squared minus 25. Some of you may think we're done. Hopefully, most of you realize that this is a perfect square and difference of squares binomial. So we can rewrite this as x plus 5, x minus 5. Again, not quite done yet, because remember, to start this, we factored out a singular variable, x. So we need to rewrite that in our final expression of x times the binomial x plus 5 times the binomial x minus 5. All right, and last but not least, we've got this big, long expression with a lot going on. But we're going to go through this the same way we've gone through any of the other ones. Don't be intimidated by the fact that there's bigger numbers, okay? What can I take out of all these? Well, my lowest coefficient is a 2, so I can't go higher than that, right? My lowest degree exponent is a 1, and each one of the terms has an exponent in it, so I can take away at least a degree of 1 variable with a coefficient of 2, so let's do that. Take away 2x. If I take away 2x, my new expression simplified out would be x to the third minus 3x squared minus 49x plus 147. If you didn't have the calculator out with you, trust me, I did. So I just went ahead and did all that. You can just write that down. Make sure you follow along with me, though. Now we're just going to continue on. I'm going to group together these two terms. I'll group together those two terms. What can I take out of x to the third minus 3x squared? Well, I could take away at least an x squared, right? X, oh, that looks like a negative. It's not a negative. X squared times the binomial x minus 3. I've got a negative 49x plus 147. What I did right away was see, does 49 go into 147? That would be the easiest GCF that we would have here. So I took that out. And it did go evenly in 3 times. So if I factor out a negative 49, I'm left with x minus 3. Now this is a negative, right? Because in our original binomial, it is a positive 147. If we factored out a negative, if we were to distribute that to another negative, like we do right here, that will give us the positive that we are looking for. So now I've got x squared times the the binomial x minus 3 minus 49 times the binomial also x minus 3. So there's our common binomial we can factor out. So now I know I'm going to have x squared minus 49 and x minus 3. But if you notice, x squared minus 49, perfect square binomial, or difference of squares, I should say, right? So we're going to rewrite that one into x plus 7, x minus 7. That's still multiplying by x minus 3, right? And we factored out at the beginning this 2x, so that's going to have to come down with it as well. So a big, long final answer of 2x times the binomial x plus 7 times the binomial x minus 7 times the binomial x minus 3. So I don't want you guys to worry about this correcting misconceptions section, okay? You guys cannot worry about that for now. And don't be intimidated whenever you get these larger valued, larger coefficient polynomials. Just take out the GCF. All the steps that you guys need to do, you know how to do. It may take you a little more time. You might have to write out a factor or two like I did here. But still, start with it multiplying by itself, cut it in half, and keep going down if you need to find the proper factors. As soon as you guys simplify out, you guys will be able to complete the steps to factor out completely. What I want to remind you guys, though, is when it says to factor each polynomial completely, your final answers need to look like here. It's not just going to be x plus 5, x minus 5 like you would with the difference of squares. We need to bring the original factor that we had with it, just like we learned, and I think that was day 5, day 4 or 5, when we originally started dividing by monomials. So hang with it. Email me with any questions if you have some. Be happy to help. And we will talk to you later.